Good morning, students. Today we will learn about the Open System Interconnection Model or the Osi Reference Model in computer networks. The Osi Reference Model in computer networks is a conceptual or logical and physical implementation of computer networks. Obviously, it is not a computer architecture, but the computer architecture has to take care of how it has to be implemented. It just tell you that what are the different levels the data have to travel from a client machine to a server machine and what has to be the input at each level. The OSI reference model are having 7 different layers. The 7 different layers you can see in the diagram. The 7 different layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. Each layer is assigned a particular task or a group of tasks to it. And I have a reminder, I have a code word to remind all these layers. That is, the code word is please do not touch Steve's pet alligator. By remembering this code word, you can remember the layer names of OSI reference model. We can see the working of OSI reference model. Here there is a sending host and there is a receiving host and you have a data to send. A message starts at the top of the application layer and it moves down through the OSI layers and it reaches at the physical layer. As the message descends, each layer adds its own header information to the data. Here you can see the application layer is adding a header information AH to the data and it is given to the presentation layer. The presentation layer adds its own header PH to AH and data and PH, AH and data is passed down to the session layer and the session layer adds its own header information SH to PH, AH and data. What is the header information? The header information is a layer specific information that is intended to read by the corresponding layer at the receiver. Likewise, the data reaches at the physical layer. At the physical layer, the data will be converted into a proper format that will be available or that will be appropriate to the transmission medium. Upon reaching the destination, the data will be converted back to its digital format and the data will be moves back upwards to the application layer and during this process the header information added by the sender will be stripped off at each layer and appropriate actions will be taken and at the application layer our data will be available to the user. Next, we will see the responsibilities or the functions of the OSI reference layers in detail. First, we will take the physical layer. The physical layers is responsible for moving data bits from one node or the sender to the next node or the recipient. The main functionalities of the physical layer is, first one is transmission media. You can use or you can have two different types of transmissions. It can be either wired transmission or it can be a wireless transmission. The wireless transmission, you will not use a wire. Instead of in transmission media, you can use coaxial cable, twisted pair cable, optical fiber cable, etc. And the next function is types of encoding. Different types of or different kinds of voltages and current levels can be used to represent zeros and ones. Zeros and ones you cannot send it as it is, but instead of representing zeros and ones you can use different kinds of voltages or current levels. That is coming under types of encoding. And data rate, the number of bits sent per each second is coming under data rate. Synchronization of bits, that is sender and receiver has to maintain the same data rate. That is what is coming under synchronization of bit. And line configuration. Line configuration determines whether it is a point-to-point connection or whether it is a multi-point connection. Except mesh topology, all the other topology or all the other configuration is a point-to-point connection. But mesh topology gives a multi-point connection. And topology is nothing but the physical configuration of the networks. We do have different types of topologies available like star topology, mesh topology, ring topology, etc. So the next one is transmission mode. Transmission mode determines or defines the direction of data transfer. That is, the direction is whether it is simplex mode, half duplex mode, or full duplex mode. In simplex mode, we can take an example. The communication between the keyboard and the system is an example for simplex mode. That is, the sender can always send, but the receiver can always receive. In case of communication between keyboard and system, the keyboard always sends, the keyboard never can receive, and the system always takes data from the keyboard. The system cannot never gives back data to the keyboard. That communication is simplex communication. And half duplex communication, the sender and receiver can both send and receive, but not at the same time. Walkie-talkie is an example for half duplex communication. Full duplex communication, the sender and receiver can send and receive at the same time. So our telephone lines is an example for full duplex communication. So these are the different functions provided by the physical layer. Next, we will see the important functionalities of data link layer. The important functionalities of data link layer is error control and flow control. Apart from error control and flow control, framing and physical addressing is also coming under the function of data link layer. What is framing? On the sender side, the data link layer receives the data from the network layer, and this data is divided into manageable units known as frames. This particular action is known as framing and physical addressing. We know that there are two types of addresses to a machine: IP address and MAC address or physical address. It is the responsibility of data link layer to add the MAC address or the physical address to each data unit or to each data frame. That is coming under physical addressing. And next important function of data link layer is flow control. Flow control, the data link layer makes sure that the sender sends the data at a speed that which receiver can receive it. That is, the sender speed and the receiver speed should be synchronized, otherwise we should have loss of data bits can happen. That is a property, or that is a correct action taken by the data link layer. And next important function of data link layer is error control. In error control mechanism, error handling mechanism, the various error handling mechanism are provided by data link layer. Like it can provide, or it can identify the lost or damaged frames, it can duplicate frames and then retransmit them. These are the two different, flow control and error control is very important functionalities of data link layer. Next, we will move on to the network layer. In network layer, the data is divided into unit known as packets, and the network layer is responsible for source to destination delivery of data packets. What is the important functions of network layer is logical addressing and routing. As a data link layer adds a physical address to each data frame, the network layer adds IP address of the sender and the receiver to each data packet. That is known as the logical addressing. And routing, the finding the best path for each data packet to travel through the network to reach the destination is known as routing. So routing and logical addressing are the two important functionalities provided by the network layer. Next, we will see transport layer. Transport layer is responsible for process to process delivery of data. Functions provided by transport layer are service point addressing or port address, segmentation and reassembly, connection control and error control and flow control at the level of transport layer. First, service point addressing or port address. That is, port address is known as the process address. That is, to exactly to which process the data is coming from and to data is delivered is known as the port address. The port address is added by the transport layer. That is what it is known as process to process delivery. And segmentation and reassembly, segmentation at the sender side and reassembly of the receiver side of the data is being done by the transport layer. And connection control, we do have two different types of connections. Either it can be a connectionless or connection oriented. In connectionless, there is no acknowledgement mechanism to the center to the center, but in connection oriented there will be an acknowledgement mechanism. When a data frame is reached at the destination will send back an acknowledgement to the sender that I got the message. So in connection oriented there will be a acknowledgement mechanism. And error control and flow control, at the these are unlike data link layer, the error control and flow control is done on the level of transport layer. Next, we will see session layer. Session layer is responsibility is beginning, maintaining and ending the communication between the sender and the receiver. So, the functions are dialogue control and synchronization. Dialogue control is responsible to determine whether it is half duplex communication have to take place or full duplex communication. Synchronization, in the synchronization process, the session layer adds some checkpoints, that is in between the data, it adds some checkpoints, that is for in case of connection failure, these checkpoints will be very helpful. So, next we will see the presentation layer. The presentation layer is concerned with the syntax and semantics of the information transmitted, and the functions provided by the presentation layer are translation. That is, in translation service, the data is communicated, or the data communicated should be converted to a message that is commonly known to the sender and the receiver. And encryption, as you know, the data at the sender side is converted to ciphertext, and at the receiver side the ciphertext is again reconverted to the plain text. That process is known as encryption. Compression, data compression reduces the number of bits contained in the information, thereby the ensures faster data transfer. So, all these functions are done by the presentation layer. Next, we are going to see the functionalities provided by the application layer. The most common functionalities provided by the application layers are FTP, the file transfer protocol, Telnet for remote login, SMTP, that is for simple mail transfer protocol. These are various kinds of application that we are using with the help of application layer protocols. So, with this I am winding up my session. Thank you all. Thank you so much.